Hummingbirds are fascinating birds, holding the title for the only bird that can hover for prolonged periods of time. In order to sustain motionless flight, hummingbirds have a wing beat up to 80 beats per second, compared to robins at only 2.3. Courtesy of the Alshore Lab at UC Riverside, you can see that in order to hover, hummingbird wings move back and forth horizontally, drawing a narrow figure eight in the air with each full stroke. This creates two distinct jets of downward airflow and surrounding vortex loops, making in-place flight sustainable. Based on fluid mechanic theories, these loops should create circulation around the wings and allow the bird to overcome its weight. This entire mechanism greatly increases a hummingbird's maneuverability, which outweighs the cost of increased energy consumption from prolonged hovering. When considering the mechanism for how hummingbirds fly backwards and hover, it is important to note that most birds do not have these abilities. Therefore, hummingbirds must have a different anatomical structure and function in their wings. Indeed, this is true. According to Tobolsky et al. 2010, compared to other bird species, hummingbirds have a larger supracoccordius muscle involved in primary wing upstroke. Hummingbirds also have a shortened humeral bone and elongated distal wing elements with rotational abilities at the wrist and elbow not found in any other bird species. As you can see in this scaled picture comparing the hummingbird's wing to the pelican wing, there is an exaggerated difference between the humerus and distal wing elements. An interesting fact is hummingbirds can survive in a wide range of temperatures. This led me to predict that hovering is a function of temperature, considering the high energetic cost of hovering and the effect of temperature on metabolic rate. Welch and Suarez in 2008 found, in decreasing ambient temperatures, hummingbirds increase foraging and hovering behavior to increase sucrose consumption, which results in a net energy gain despite costs of hovering and thermoregulation. Hummingbirds differ from other closely related bird species in that they do not share the characteristics of prolonged hovering with any other birds. However, they do share the behavior with many insects. Despite the similarity, I believe that this trait evolved for different reasons from different ancestral lineages. In Warwick et al. 2005, it is explained how different selective forces were imposed on hummingbirds versus insects. Hummingbirds needed to meet the demands of a high-energy flux way of life, while insects needed a form of locomotion in fluid medium. More evidence lies in the differences of the aerodynamic styles between the two organisms. So what's the point? Why do hummingbirds use this energetically costly form of flight anyway? It seemed reasonable to think hovering increases foraging efficiency. However, Miller 1985 reports hummingbirds will preferentially perch when available. It is actually the architecture of the plant that makes hovering useful. Many of the plants in the hummingbird diet that contain high nectar volumes do not have available perches, making hovering an essential tool in obtaining nutrients.